Magnificent makers, exceptional electronics enthusiasts, superheroes of CircuitPython, and people who are passionate about the Pico W. It's Prof G, and in this lesson we're going to write a small amount of code and learn how to remotely control the Raspberry Pi Pico W over the internet using a simple drag and drop web interface that you can easily create. We're going to be using MQTT and Adafruit IO in CircuitPython. It's all free, and by the end of this lesson, we'll be turning a NeoPixel strip on and off by pressing a button in a browser, and this will set us up for our next lesson where we'll change colors, play sounds, and move a servo, all from a drag and drop web dashboard that we'll create, and we'll eventually use what we learn here to build a remote control Pico W powered robot. Let the big learning commence! So if you're here, I'll assume you have a Raspberry Pi Pico W with CircuitPython installed, and it's configured to connect to the internet over your Wi-Fi network. If you follow the installation instructions from our playlist, then you should have the libraries that you need. If you're new here and you need to set things up, see our playlists. There are plenty of lessons that'll get you ready. Now in this lesson, we're going to learn to create and connect a web dashboard to our Pico W. We'll send messages to the Pico W, and we'll write CircuitPython code on the Pico to receive those messages and perform a task based on the message received. Now the way we make this happen is by using a communication scheme or protocol called MQTT. MQTT stands for Message Queue Telemetry Transport. It was originally developed by IBM, but it's now open source, and it's one of the most popular ways to get devices to communicate with each other over what's called the Internet of Things. The Internet of Things, sometimes called IoT, pretty much refers to smart devices that send and receive information or that can be controlled over the internet. Now for MQTT to work, we need three pieces. A publisher that sends out messages. For us, the publisher is going to be our web browser dashboard. We'll start out by publishing a message that says on or off. A subscriber, which subscribes to or waits around for published messages so it can respond to the messages that are received. For us, the subscriber is going to be a CircuitPython program running on our Pico W that's connected to the internet. And in between the publisher and subscriber is a broker. The broker's job is to receive incoming published messages and forward the appropriate message to the subscriber that subscribed to them. So again, we create a dashboard that acts like a publisher and that will send on-off messages. There's going to be a middleman broker, that's going to be Adafruit IO, which will receive all incoming messages and will look to see who subscribed to each message. In our case, that's going to be the code running on our Pico W, and the broker will forward that message. The Python code that we write will recognize this message. In our case, it will be the on or off message, and if our code receives on, it will turn our light strip on. If it receives off, it will turn the lights off. Now, the first thing we need to do is to create a free account at Adafruit IO, which is going to act as our broker. So open a browser and head over to io.adafruit.com. Now, if you've already logged into Adafruit, your screen may look different from this. We'll catch up to where you are in a bit. But if you're not logged in and you have an Adafruit account that you might have used either for shopping or their online forums, you can use that account for Adafruit IO. So feel free to log in now if you'd like. But if you don't have an Adafruit account, you can head up here and click on Get Started for free. If you want to create a new account for Adafruit IO, you can log out first, then click on Get Started for free, enter the standard account creation information, and click Create Account. I'm creating a new one here that's different from my shopping account just to demonstrate this. So at this point, we've created an Adafruit account, so head up to the I/O tab, and now you'll see some information about Whippersnapper. This is Adafruit's no-code way to connect devices to the internet. It's very cool. Feel free to explore this if it's of interest to you. If you're interested in Whippersnapper, there's a great Learn guide on the Adafruit site written by Brent Rubel, who created Whippersnapper. Brent's a great person to follow online because he's also done lots of work with Adafruit's other IoT tools, including some of the tools that we're going to be using. But we want to write custom CircuitPython code, which will give us more flexibility and control, so we're going to ignore Whippersnapper. And instead, we're going to head up to Dashboard, which will let us create on-screen elements that can publish messages that our subscriber program will read. Now, there's a welcome dashboard already in here. You can return to check that out later on if you want, but let's click on New Dashboard to create our own dashboard. And you can give your dashboard a name. I'm going to call mine remote_control. You can do that too if you want your code to be just like the code that I'm going to write. And then I'll click on Create. Then I'll click this remote control link that was just created, and I don't have anything in my dashboard yet, but I'm going to head up here to this gear icon in the upper right and click that and select Create New Block. Now there are lots of elements that we can create and add to our dashboard. Some are input blocks that allow us to publish values, like this toggle or on-off switch, a push button, a slider, there's a color picker down here, and there are also output blocks. These are really useful if you want to gather data from a sensor and display it. So for example, this one here shows data in a gauge format. Down here, you can present data in a line chart. For now, let's click on the toggle up here, which is a switch between two states. Next, I'm asked to select a feed that this block is going to be associated with. Publishers send information to a broker, and that's what's called a feed, a data feed, and the subscriber will subscribe to specific feeds. Now, there's a welcome feed that's here, but we're going to ignore that, and instead we're going to create our own. So let's enter a new feed name down here in this box. I'm going to enter strip underscore on underscore off. That's going to be a feed that will turn a NeoPixel light strip on or off. You can absolutely use a different name if you would like to. Just press return when you've entered the feed. The feed is created, we see it in the feed list, then click the checkbox to the left of the feed name and click the next step button in the lower right. Here we enter a block title that'll show up in the upper left-hand corner. I'm going to enter a light strip since this block will turn the light strip on or off, and I'm going to leave the button on text and off text just as shown. So in all caps on for button on text, in all caps off for button off text, these are the messages that are published to the feed when the toggle is flipped on or off. Now we can ignore everything else and just click on create block, and look at that, we've got our first dashboard block. You can try it out if you want, but it doesn't do anything since we don't have any subscribers. But when we click on or off, we are publishing data to a feed named strip underscore on underscore off that sends the message in all caps on when the toggle is on and in all caps off when the toggle is off. Now with your Pico W plugged into your computer's USB port, let's open our Mu editor. Again, we learned how to download and install the free Mu program in an earlier lesson, and I'm going to click on the new button in Mu to create a new file. So if you've worked through our Wi-Fi lesson, you know that we've created a separate file called settings.toml. It doesn't end in pi, and that file contains our environment values where we store things like our Wi-Fi network name and our Wi-Fi password. Well, we're going to recreate that file now, and we recreate the file because Mu unfortunately does not yet let us open a .toml file. At least that's the case at the time that I'm recording this lesson. Hopefully Mu will update that. So we're going to create a new file and just overwrite the existing toml file. That'll work fine for us. So with my new file up here, I'm going to enter a comment stating that this is a settings.toml file. Then we'll create a value in all caps, Wi-Fi underscore SSID, and we'll set this equal to the string, so double quotes, and between the double quotes, enter the name of your Wi-Fi network. So if it's your home Wi-Fi network, that should be exactly as it appears on your computer or your smartphone. Then below this, in all caps, we'll enter Wi-Fi underscore password and set this equal to, between double quotes, the password to log into our Wi-Fi network. Again, make sure that your password's spelled properly. And if this is sensitive information, just make sure that nobody has access to your Pico W where they might read this file and get access to your Wi-Fi password. Then below this, I'm going to create a value in all caps, AIO underscore username, and set this equal to my Adafruit IO username. So in this example, it's Prof Gallagher, all one word, all lowercase. Be sure to use your Adafruit username, not mine, or it won't work. And again, this is a string, so make sure that your username is in between double quotes. And then below this, I'm going to enter AIO underscore key and set this equal to a string, which is the key for your Adafruit IO account. Now I'm going to show you where we can find this information in just a minute. But beforehand, let's finish up this file. We're going to enter broker in all caps below this, and we'll set this equal to the string io.adafruit.com. That's the address where the broker is. And then in all caps, we'll enter port, P-O-R-T, and set this equal to, and this is not a string, so no double quotes here, it's just a number, 1883. Now this is the software-based connection port that'll allow our Pico to find the broker at io.adafruit.com, so we want 1883. And so now let's go back to Adafruit IO in our browser and find the key so that we can replace the value that we entered here. So in our browser, we're still logged into Adafruit IO. I'm going to click on the key in the yellow circle in the upper right-hand corner, and this brings up information on how we can configure Adafruit IO for various platforms. But what I just want to do is copy this active key that I see here, highlight that, copy that. By the way, you can also regenerate the key if you need to. If, for example, like me, you're creating an internet video and you don't want the whole world to have access to your Adafruit IO account. So I'm going to regenerate this key afterward so this key doesn't work. But if you regenerate your key, make sure you go back and change your setting.toml file with your updated Adafruit IO key. Otherwise, you won't be able to connect to Adafruit IO. Then I'll press escape to cancel out of this window, head back to moo, and I'll paste this value into the string for my AIO underscore key value. And then this is very important, do not double click on the tab to bring up the save as dialog box in moo. At least at the time where I'm recording this, there's a bug in moo that doesn't properly save this file when using save as. So instead, I'm going to click on the save button and be careful. So our file name is called settings, all lowercase, but we want to make sure that we come down here to the pull down menu for file type and switch from .py to other. So make sure you select other, and then we'll finish out the file name. It should be settings.toml, all lowercase, no spaces in there. Click save. If you're writing over another file, that should be fine. And it's worth taking a look at your CircuitPy volume just to make sure that you have a file in there that's named settings.toml. I do have that. The file should not be called settings.toml.py or settings.py. If that happened, you have an incorrect file in there, throw it out and recreate the file, making sure that it's saved as an other type with settings.toml as its name. Now, since this is part of my setup files on my Pico, I'm going to make a backup of settings.toml. So on my desktop, I've already got a folder named Pico W backup, and that contains a copy of my lib folder that has all of my libraries in it. So I'm just going to drag settings.toml into this folder here. It doesn't go in the lib folder, it's at the root level of the Pico, but now if I ever need to set up a new board or reinstall files on my current board, I've got a backup and I don't need to recreate that file. So with that done, we can now close this tab and click on new and begin to write our CircuitPython code. And before we write that code, let me briefly talk you through the code we're about to write. So first, if you work through our Wi-Fi lesson, this code is familiar to you. We're importing an additional library here though. It's Adafruit underscore MQTT, getting Adafruit underscore MQTT, and calling this MQTT in all caps in our code below. Now this is where we connect to Wi-Fi, and we set up something called a pool for communication over Wi-Fi. We learned about this in our prior lesson. Again, this is all repeated code, which is nice. We don't have to make any changes up here. Now down here, I set up variables to hold my Adafruit IO username and my Adafruit IO password, and I'm creating a value named strip underscore on underscore off underscore feed, which is my username plus /feeds /strip underscore on underscore off, which is the name of the feed that I created and associated with my toggle button when I set up my dashboard. Now I've highlighted this in a green box since this so far is the only code that you might change in the future when you write your own programs to respond to your own dashboards and do different things on a Pico W. So if you have a different feed name, you'd use that here, and in a future lesson I'll show you how you can add more than one feed. At that point we'll just create different values to hold the names of the different feeds. Next, we've got three main things that we need to set up when working with MQTT. So we're going to create three functions for that. Now the code that we're writing is for a subscriber, so we want to connect to our broker. So that's what we're doing in the connected function that I've defined here. This line that I've highlighted in green here subscribes specifically to the feed that we've just created. So when you write code in the future, you'd change this to a different variable name if you've got a different variable name for your feed, or you might subscribe to multiple feeds so you'd have multiple lines in here. And again, I'm going to show you how to do that in a future lesson. Now this next function that we have here, disconnected, is going to be called when we disconnect from the broker. We just print a message to the console so we know that that happened. Again, you shouldn't need to change this code in any future code that you write. And the message function down here is called when we receive a message from the broker. And you can see I've highlighted this area in green, which is specific to our program. Now what we'll do here is we'll print out the topic, which is the feed name, and the message that we receive. And we should be receiving one of two messages, either the string on in all caps, because remember, when we set up our toggle block, we had on as one of the options in the dashboard, and if we receive that, we're going to turn our strip red, or if we receive off in all caps, we're going to turn our strip black, which essentially turns all the lights off. Now I didn't show you the code to configure the NeoPixel strip since we've already done that in a bunch of lessons. We will write that code together in moo in just a bit. Now this last slide of code is the code to set up the MQTT object, so that'll be standard. And once we've created that, we attach the connected, disconnected, and message functions that I just showed you on the earlier slides, and then we call connect to start our connection to the broker. And then in the while true loop, we simply call MQTT client.loop over and over again, which will repeatedly check check to see if we have any new messages or if we've disconnected. And that's it. So if you want to do anything else outside of MQTT, maybe respond to a button press on a button that's connected directly to your Pico or anything like that, you could do that in the while true loop in here. But with this covered, let's head back to Moo and write code to get our Pico responding to our dashboard toggle. So I'll start with a comment, MQTT demo -Adafruit IO, and we'll import the libraries we need, import board, time, neopixel, and then these are the ones specific to Wi-Fi, import OS, SSL, socket pool, Wi-Fi, and then this one is specific to MQTT, import Adafruit_mini MQTT dot Adafruit_mini MQTT, and we're going to call that, so we'll say as, in all caps, MQTT, so that'll be the name that we use to refer to this library in our code below. Then I mentioned we're going to set up our NeoPixel strip. We're going to call this strip and set it equal to neopixel, capital N, capital P. And in between parens, we'll pass in board dot, and I'm going to attach my NeoPixel signal pin to GP15. If you're using a different pin, make sure that you set that here, followed by comma and 30 because there are 30 NeoPixels on my NeoPixel strip. Then I'll create in all caps red, setting this equal to the tuple, so in parentheses 255, 0, 0. Then I'll create black in all caps, setting this equal to the tuple 0, 0, 0. And I'll turn off all of the lights initially, so I'll set strip.fill, passing in between parens, all caps black. Then I'm going to get my Adafruit IO username and key from the settings.toml file. So I'm going to put the username in a variable that I'm going to call AIO_username, setting this equal to os.getEnv, so that's the get environment operation in the OS library, and in between parentheses I'll pass in the string AIO_username as a string, so it's between double quotes, and we learned in our Wi-Fi lesson that os.getEnv gets any lines that we've set up and named in our settings.toml file. So remember, earlier in this lesson we set up our settings.toml file and we created a line AIO_username with your Adafruit IO username in there. It's going to put that value in the AIO username variable. Then down below, we'll say AIO_key, and this variable is going to be equal to os.getEnv, and in between parentheses, we'll pass in the string AIO_key in all caps. Then below this, let's set up a feed to subscribe to or listen to for messages. And just to make sure this is completely clear, I'm going to head over to my browser, and if I click on the Feeds tab, I can see I've got two different feeds here. Now, the one that I'm going to use is this one that we set up, strip_on_off. Then if I click on Dashboards, the only dashboard we've set up is called remote_control, but if I click on that, let's look at the light strip toggle. So if I click on my little gear, I can edit layout. I can click on the little gear next to the light strip toggle and click on edit block. I can see this block has a check mark next to strip_on_off. So that's the feed that this is attached to. And if I click on next step, I can see that this button is going to send the string ON in all caps when it's on and OFF in all caps when it's off. So now let's go back and use this in our code. I'll first create a variable called strip_on_off_feed and set that equal to my AIO_username plus the string /feeds. So all the feeds for a particular username always start with /feeds, then /strip_on_off. Remember, that's the feed that we attach to the toggle that's on our dashboard. Then below this, we'll set up functions to respond to MQTT events. And first, we'll define DEF space, a function we're going to call connected with ED at the end. And between parentheses, we'll pass in client, user data, flags, RC, in parens, and enter a colon. Those are all standard parameters that you're going to pass in, so you'll never change those. And when this is called, we've connected to the broker at Adafruit IO, so we'll just print out a statement that says connected to Adafruit IO, listening for topic changes in feeds I've subscribed to. And it would help if I spelled print right. And then down below, we're just going to subscribe to all changes on the feeds mentioned below. And it's only one feed we're going to monitor. So to subscribe to that, we say client.subscribe, passing in strip_on_off_feed. And I forgot to enter a closing parens. We'll get an error, but we'll fix that in just a bit. Then below this, we need to create a disconnected function with def space disconnected with ed at the end. And between parens, we'll pass in client, user data, RC. Make sure you close parens and have a colon at the end. This is called if we've disconnected from the broker at Adafruit IO. And if that happens, we'll just print out a statement that says disconnected from Adafruit IO. Then down below, we'll set up the function that's called whenever we receive a new message from the broker. So we'll say def space message, passing in client, topic, message, close with a colon. So the bulk of the code that responds to MQTT will be in here, not in while true. And first, just to make sure that we can understand what messages we're receiving, I like to print out in between parens an F string, F and between double quotes, topic colon, curly braces with topic in between, comma, message colon, curly braces with message in between. Make sure you end with a double quote and close with a paren. Then if message double equals the string on in all caps colon. Remember that's the text that's sent over when we have a button on event when clicking on the toggle in the dashboard we just set up. And if that happens, indented below this we'll call strip.fill, passing in between parens in all caps red. But if we didn't get on, let's outdent and we'll say elif on the next line, message double equals, and in double quotes, off in all caps colon, we're going to set strip.fill, passing in all caps black. So that's it. That's the code that responds to the on message where we turn it red and the off message where we turn it black. Then below this is our standard connect to Wi-Fi code. I'm just going to print out an F string that says connecting to Wi-Fi, and then we call wi-fi.radio.connect, passing in os.getEnv, and in between parentheses, in all caps, it's the string Wi-Fi underscore SSID, so that gets the name of our Wi-Fi network, comma os.getEnv, and in between parentheses, we pass in the string Wi-Fi underscore password in all caps. That logs us into Wi-Fi. Make sure you've got your closing double quote and your two closing parens, and on the next line, I'll just print out connected. And once again, I need to make sure that I spell print right. Then when setting up Wi-Fi, we also need to create a socket pool, so we'll just create a variable called pool, setting this equal to socket pool, all one word, all lowercase, dot socket pool, capital S, capital P, and in parentheses, we pass in Wi-Fi.radio. Again, if that seems like gnarly code, well, it's just code that we repeated that we used when we originally set up Wi-Fi. You can go back and check out that lesson if you need to, but we're going to repeat that whenever we need to connect to Wi-Fi. No big deal. Then below this, we'll set up our mini MQTT client. This is our current program that subscribes or listens. And we're going to call our MQTT client just MQTT underscore client, and we're going to set this equal to, in all caps, MQTT. That's the name we set for the library we imported above. Within this library, we'll call .mqtt to set up the MQTT class, and then in between parentheses, and I'm just going to put these on separate lines because there are a lot of parameters to create an MQTT object, and it'll be easier to read this if I formatted this with the different parameters on separate lines rather than putting them all on one line that won't fit on screen. I'm going to set broker equal to os.getEnv, passing in between parentheses the string in all caps broker, comma, port equals os.getEnv, in between parentheses the string port in all caps, comma, username equals AIO underscore username, we defined that above, comma, password equals AIO underscore key, comma, we defined that above, socket underscore pool equals pool, comma, SSL underscore context equals SSL dot create underscore default underscore context open and close parens. Now that's a gnarly bit of code, but you'll probably never change that whenever you set up an MQTT client. If you're curious about SSL, it's a standard that's used for web encryption. It just sets up some necessary data structures for longer connections to the broker. And make sure there's a close paren down below. That's quite a bit of code to set up your MQTT client, but it should be pretty much the same in any code you write in the future, so you can copy and paste that just like it was a software Lego. Then below this, I set up the callback MQTT methods that I created above, and I do this by setting up the MQTT underscore client variable I created above, followed by .on underscore connect equals connected, so that attaches it to the connected function I wrote above. Below this, MQTT underscore client .on underscore disconnect, setting this equal to disconnected. That's another function I defined above. Then MQTT underscore client dot on underscore message equals, and you guessed it, message, which is the third function we defined above. See those three guys we got up here? Excellent. Then it's time for us to connect to the MQTT broker, which is Adafruit IO for us. So we'll just print out connecting to Adafruit IO, and the way that we do that is we call MQTT underscore client dot connect open and close paren. So that's a connect method. And then we have our while true loop. Make sure you got a capital T and you close with a colon. And we only write one line of code in here to keep checking the MQTT message queue. That's MQTT underscore client dot loop open and close parens. And if you had any other non-MQTT code in here, you would just add it below. Then I'm going to go ahead and save this to my CircuitPy volume, and oh, I can see in my serial console that I've got an error in line 27. It's actually not in line 27, it's in line 25. Moo does that sometime, but I pointed this out before. I forgot to add a closing parenthesis in line 25. We'll add that, save again. No errors this time. Connected to Wi-Fi, connected to Adafruit IO. We're listening to topic changes, so we subscribe to our feed. Let's head over to our dashboard. Let's click that toggle, and oh, look at that, the lights turned on. Click, oh, the lights turned off. Turn them on. Turn them off. Now we see we got a little message up here. If you got that message, you can click on the X, but it is possible to send too many messages in the free version of Adafruit IO. I'm just going to click away, off on, as much as I can. You can see how many messages I'm sending. And if I keep clicking up, eventually I'm going to get the throttle warning up here. It says Prof. Gallagher, data rate limit reached, 42 seconds until the throttle is released. So I can close this. Unfortunately, it doesn't give me a countdown clock. If I try to click again, I can see I still got some time to go. I really have to wait right up until the end. But eventually I'll be released from the throttle and I'll be able to turn things on and off again. Now, if you wanted to have more messages, and again, you can send, I think it's 30 messages a minute, so a message every 2 seconds. But if you needed to double that rate, you could pay $10 a month to Adafruit IO and you'd have access to more throughput. And you can see the throttle is now released and I have access to my dashboard again. So Pythonista, we ought to save this code to our CircuitPython school folder. I'm going to call mine MQTT-with-Adafruit-IO-and-Pico-W. I'll close this up and load the code back off my Pico. But Code Monster, you are now an MQTT magician. You are building web-based dashboards and using them to control your Pico W over the internet. That is some savage skill. We'll up the ante in our next lesson where we'll learn more techniques for working with different controls, for changing colors on our LEDs, for manipulating servos, for playing sounds. We'll eventually do some online ventriloquism where we make toys speak from a distance, and we'll eventually build a robot that we can control via an MQTT dashboard as well. Now use those skills to make something awesome.